Well, welcome back. We have with us today semi-retired petrochemicals and chemical industry SME Bill Valerioti, also affectionately known as Bill Val. So, Bill, welcome to the show today. Thanks for coming.
Thank you, Brandon. My pleasure. Thank you for having on as your guest today. I look forward to a good conversation today with you all.
We talked a little bit just as we were kind of getting set up here, and I know you've got a little bit of background and experience here in the mechanical integrity industry. Can you just give our listeners a picture into kind of where you're an SME, how you're an SME, where you came from a little bit, and touch on a couple of those key points?
How you started, Bill. And the only other thing I mentioned for our listeners here is he's got experience in the refining industry as well. But Bill will get to that. Go ahead, Bill. Sorry.
Yeah, I appreciate it. Yeah, thank you. Good question. It really started with my college education. I grew up in Florida and decided late after, in the senior year to attend the University of Florida. I was good at science and math, and so engineering seemed to be a natural fit. Started out in chemical engineering, but it just wasn't clicking. I wasn't motivated. It didn't sink in with me. And so I took a year off. I took a year off and worked some construction jobs as an electrician's helper. And then I realized I wasn't passionate about that, as kids say today. So I found my way back to school and took an intro to materials class, which was on the schedule for your third year of college. And I just fell in love with materials engineering and corrosion. So that's how I really became learned in materials and their properties and corrosion and failure analysis through courses at the University of Florida. And as luck would have it, one of the professors there, Professor Emeritus at the University of Florida, a Dr. Ellis Farink, was active in NACE. And if you're familiar with NACE, now known as AMP, he's written a lot of publications about engineering economy and design for corrosion control, and really a great person, a great human being. And he was an acquaintance with a fella at Phillips Petroleum in the materials lab, RC Bob Schuler. And they were both involved in NACE, and Bob put some feelers out, at the conference that they were looking for a summer intern. And lo and behold, Ellis Farink recommended me to go out and take that position as a summer intern. And I asked myself years later, how did I impress upon him that he would recommend me for that job? I wasn't top of the class. I was a good, solid B plus student, close but no cigar a lot of times. But I really think it was because I came prepared to his class. As I said, it was a corrosion engineering class. I loved it so much that I used to read ahead, and I was able to answer a lot of questions. And so that's how I got hooked up with Phillips Petroleum Company in Bartlesville, Oklahoma, in the materials engineering lab. And this is in 1981. So it really was a phenomenal experience. And then working in the failures analysis lab, most of the staff there were in their 50s and 60s. There was a big age gap due to the cyclical nature of petroleum exploration, production, refining. And so there was large gaps in hiring. So that's how I got into it. I learned a lot supporting the plants. We had assignments, of course, material support assignments for our manufacturing facilities, primarily in Borger, in Sweeney, Texas, and Adams Terminal, now known as Pasadena Plastics, in Houston. And each materials engineer had an area of responsibility, both a facility, but also a process. And some of my processes that I was responsible for were the sulfur units, the Klaus units, the HF alkylation. As many people know, Phillips Petroleum was a licensor of that technology before they sold it to UOP. So I supported that, and the high temperature business. So crude furnaces and ethylene, the hot end of the ethylene furnaces. And as part of that assignment, we would put on biannual equipment inspection conferences, right? Internal training, knowledge transfer sessions folks, put together some papers and learnings, and we would bring primarily the equipment inspectors, the company inspectors, and share technology with them and knowledge and information. And, I did that 2 or 3 times. And, it's about 1991, 92. And I made a presentation, and in the audience was the EH&S manager from Adams Terminal, Pasadena Plastics. And they had a equipment inspection program. It was really, really young. It really wasn't functioning at the level it could have been. And so he approached me and approached my boss with an opportunity to transfer to the Eastern Chemical Complex, Adams Terminal, and to really take over and lead the equipment inspection group. And so that really, so you have a background in materials, failure analysis, support, communicating, teaching, transferring knowledge. And now you get to get your boots on the ground where the rubber meets the road. And, okay, big dog, you've been telling us about how to do things better. Well, now we're going to see if you can really drive change and implement, an improvement in the program that we have here in Houston. And I wanted that opportunity. I really was raised, as we said earlier, Greg, to be a problem solver, to figure things out. My dad and mom always emphasized education. My dad was Mr. Fix-It. He was a phenomenal person, an electromechanical draftsman, designer who had a garage full of hardware, disassembled lawnmowers. He had models of upright scooters. He turned roller skates into one of the first scooters and had patents. So he was always tinkering, and I just was awed by that. And I was kind of a blue collar guy and always felt comfortable in the environment and the scale of a petrochemical complex. It really made an impression upon me. And so I wanted to work in that environment. And one of the other things that really drove me was, I felt I was spending a lot of time becoming good at analyzing failures and understanding, why and how things failed and what we could do to improve the situation. And of course, I learned a lot by leaning on inspection personnel, because as many of you know, when failed components get shipped off, it's usually the equipment inspection group that is tasked or voluntold to send that to the Met Lab, and get it analyzed. So that's your primary contact. You learn a lot from those folks. And so that was really, my introduction to, I would say, fixed equipment inspection, mechanical integrity, because now it's 92, 93. The OSHA regulation is promulgated now, 1910-119J. And so we're immersed in that and understanding that. And now we really have, the terminology, mechanical integrity. So I would say that's how I came about, entering the field, the industry, the profession, and really have never looked back, have been involved with it really ever since, directly and indirectly.
Well, Bill, your time, if I could add, your time in Bartlesville, the early part of your career, how can you say something about how important that experience being around a failure analysis lab and then having maybe some excellent mentors around you? We don't have time for mentoring much more these days. How much did you learn from that experience?
It was amazing and incredible. There were, a large room, in the days when everyone was in a large room with desks and chairs literally separated by an arm's reach, and the materials engineers, the painting coating guys, the ceramists, the ceramics, the welding engineers were in there. And you had, a tremendous exchange of information in mentoring, because you would seek knowledge and input from others, not only about the component that was submitted, but the process. Because for someone with a mechanical background and trained in materials engineering and corrosion prevention, you need to know about the process. I can't emphasize enough how important it is to understand the process chemistry and then the actual operation, both the written operating instructions and procedures, but also trying to sit and visit with operators and really understand that. And I was able to do that and learn that not only from my time in the materials engineering laboratory, where we shared so much information and knowledge, but later on, when I assumed the position, over the position in Houston, now I had access directly to operators. And one of the things that I felt, hold us back in the materials lab was the operator would not get on the phone. It was unheard of that you could get a unit operator, to answer some questions long distance. It was a secondary or tertiary kind of exchange for the equipment inspector on site to maybe go back and get some more information. So I really learned so much from so many people. And I actually made a list of people who I learned a lot from. And it's a list of some 50 people. Wow. And it spans the backgrounds of operators, fixed equipment inspection personnel, both contract and company. I've learned a lot from maintenance people. I haven't mentioned it yet, but after my time, 3 years with the fixed equipment inspection group, I was given the opportunity to lead the mechanical engineering group for a polypropylene unit. And then I became the polypropylene maintenance superintendent, where I learned a tremendous amount of information, spent a lot of time in the maintenance shops, in the P&T with the pump and turbine mechanics, with scheduling and planning. And I learned the importance of scheduling and planning and maintenance and pre-staging jobs and getting all the right information and coordinating with operations. So I would leave this piece of advice with mechanical integrity, fixed equipment, analysts, inspection personnel. Look for opportunities to expand your base by making an impression, by solving problems, by owning problems and solutions. If you bring a problem, bring a proposed solution. That's what middle management and upper management is looking for. People that are willing to take ownership and drive solutions and coordinate and motivate people to impart positive change. So just like I asked myself, and I mentioned earlier, well, why did the professor at the University of Florida recommend me for that position? Because I was out there with solutions and answers that were, based on the information I learned from the textbook. But the other opportunities that opened up for me in Houston at the manufacturing facility, it was because I was willing to get past this is wrong, that's wrong, to finally turn the page on that and get to a solution, and not only propose what the solutions could be, but to take ownership and say, we'll implement it. We'll follow this and we'll get this implemented and we'll take ownership of that. And I think if you want to know what middle managers and what catches someone's eye, it's the people that are willing to put their time and their knowledge and their decision-making and their collaboration on the line and implement positive change and get things done in a manufacturing facility. And with those opportunities, as I mentioned, as a mechanical lead, as the maintenance superintendent, and ultimately I became the operations superintendent of a polyethylene unit. And if you think about it, there's so many different perspectives now. I started in the materials lab when I was seeking knowledge and information from those various entities, right? Maintenance, how did maintenance influence? What were the maintenance procedures? What preventative maintenance? What did we do? What did we not do? How was it operated? And here in 12 years, from 1981 to 1993, I find myself now in some of those roles and learning on the other side of the fence. And I brought my original perspective and knowledge with me, and I got a really good appreciation. So, and again, I think I had those opportunities because I was a change agent. I was willing to dig for not only the root cause of issues, but later on, drive some of those solutions. So that would be a piece of advice to people. The other thing I learned from the School of Hard Knocks was, when you start out in the corporate engineering world and you start to emerge as an expert, you have to be careful. It isn't just about reporting the facts. It's how the facts are reported, and to give due consideration of other perspectives and other constraints, whether they be business constraints, operating constraints, limits, challenges in the budgetary area. And so what I learned after some rough patches was I needed to be more considerate and have a broader perspective. It wasn't just about this is why it failed and this is what we need to do and how to prevent it. Well, maybe we couldn't do that right now. We couldn't do that right now because of the turnaround schedule. Parts are not available. And so I learned that to be careful and consider others' perspectives and to choose my words carefully, especially my written words, but also my verbal communications. You think a lot of times the equipment inspection or MI group it goes back and forth over the years from the safety group, process safety, safety H&S to maintenance to technical. And when it tends to reside in safety, you feel that, you represent, the personnel safety and process safety. So we're going to do this and you have to do this. And this is the way it is. Well, you quickly learn that may be the case, but, we have to get from point A to point B after diverting to a midpoint, and maybe monitoring or managing a situation because we're not able at this particular time to implement. So those were some learnings along the way. Don't overlook the importance of verbal communications, considering people's positions, perspectives, the politics of it, for lack of a better word, and to be positive and willing to adjust and moderate and find, manageable solutions to what you think is a black and white issue, because it may not be that way right now.
I understand that concept. Actually, I talk about with Greg, I've talked about this here at home. I talk about there's old Brandon and there's new Brandon. And new Brandon is ever since I've gotten married. Old Brandon was before that. And old Brandon did not understand the concept of, I'll call it bedside manner, right? Doctors, I don't know if you've ever had a doctor with very poor bedside manner. I fell into that a little bit. I was a bit crass. And so I definitely understand the point of like making sure that you see all the perspectives, you understand everybody's side, and that you try to utilize even just the tone in which you give. You can say the same sentence two different ways and it comes off very, very different. I'm learning that now with my daughter who's 5, and I am seeing myself come out in her, and I'm like, ooh, okay, we need to make some changes in a couple of things there. So I can definitely relate to that for sure.
Yeah, absolutely. Absolutely right. And another layer to that is body language and facial expressions. I had a tendency, if I'm hearing something I don't think is quite right, or maybe a little light on the facts and technical support, my face would express that. You need to contain that and be stone-faced sometimes or have a poker face. I mean, a really impactful learning I had was totally blindsided. It was about 1991, and this is going back to when I was in the materials lab, and we had a refining ARDS unit, an atmospheric residual desulfurization unit. And we had some temperature excursions, some reactions due to maldistribution of flow, and they culminated in some elevated temperatures at the reactor outlet. And there was some doubt about the integrity and the reliability and the truthfulness of some TIs, some temperature indication devices, and the operators didn't quite believe it. Well, they should have believed it because they were real. The bottom line is we had a overtemp, we had a rupture, we had a breach of pressure boundary, we had a release, we had a fire, and all hell breaking loose. So There was two reactors, the reactor that had the incident and the nearby reactor that needed to have a damage assessment, a fire damage assessment. And we brought in DNV for that, and they helped us with that. We had company experts. We had a lot of support. And I was the company liaison. And well, we were looking at the microstructure. Of course, the arch reactors were some 11 and 3/4 inches thick, 2 1/4 1 moly tempered steel, big single forge rings that were welded together. They were in the 1980s, late 80s. They could only be manufactured by companies like JSW, Japan Steelworks, and some companies in Europe. And so these had to be shipped. And so the lead time was incredible, as you can imagine. And of course, as you know, if you've ever experienced fire damage, you have the technical people coming in doing the fire damage assessment and the evaluations, but you also have project people that are itching to get going on the rebuild, and they're pushing hard, and they have to pull some levers and strings. Well, bottom line, to cut to the chase, is from the cord samples, where we literally had what I call a carbide hole saw, a diamond hole cutting saw. We cored, 3 samples of affected areas on the primary affected reactor involved in the incident, and the fire exposure to the nearby reactor. And it turned out that the reactor that had the release truly was, the heat treatment was adversely affected. And there was a mixed mode microstructure in there. It wasn't a tempered martensitic bainitic structure. And, the properties were compromised. But on the adjacent reactor, there wasn't any measurable visual evidence or physical hardness testing, impact and tensile testing, degradation of the properties. So, we went in and had a big meeting at the refinery with corporate engineering, corporate reps. And, we reported the results and made the recommendation that we as a company only need to replace and order 1 reactor. And this was said in front of the refining manager, the manager of corporate engineering. Well, unbeknownst to me, and maybe I should have known, or my manager should have known, we probably should have sat down with, the corporate engineering manager and discussed some of our findings, because they had hedged their bets and they ordered 2 replacement reactors, and they had to put up non-refundable money.
Oh, man.
And it's almost as if at that point, politically, for my career and for corporate engineering saving face in front of the refinery manager, I should have jawboned a little bit and said, it's probably best that we replace both reactors. So now that's pretty far stretched in terms of the implications, but don't overlook the parties at the table and who signs your paycheck. And it isn't always just the facts. Now, having known that, I don't know, I would not have reported any different results, but I would have put in some sweet words about, why we understand it makes sense that we do this, do the delivery and scheduling purposes. You had to get it on order, right?
Right.
I mean, I don't recall how long the materials evaluation went on, but it probably was 4 or 5 weeks, and time was of the essence. So,
Bill, how thick were those reactors again?
They were 11 and 3/4 inches thick, as I recall.
Wow. Yeah,
And they were really the first literally, but this is when we implemented J factor, control to manage and mitigate temper and embrittlement, right? We were tightly controlling the phosphorus, the sulfur, the antimony, the tin, the grain structure. And of course, you're interested in a tempered martensite upper bainite structure because you want the properties, you want the strength in those reactors, so they don't need to be 14 inches thick, right? And to get them to be 11 and 3/4 inches, you want mechanical properties, and so they need to be a tempered martensite. But that's when the industry was seeing the loss in the Sharpie V-notch impact testing results when you had the older grades of 2 1/4 chrome 1 moly that hadn't had J factor and controlling the weld chemistry. And so, we were able to do that testing.
Isn't that amazing, Bill? Could you say a word about, when I go back and look And my background is chemistry, not metallurgy. But when I look at some of this stuff, I'd go back and see some of the work that the Materials Properties Council had done,
Yeah.
that the Welding Research Council, WRC, and MPC, and even going back to Case Western and a lot of their original work that they did there, right? Guided U-bends and other stuff. How important is it that the industry maintain those types of records and technical basis to maybe try to understand how we got to where we are in our understanding of materials properties and the different things like J factors and so forth, flow stress now that we're using and other stuff?
Yeah, I think it's incredibly important, and I'm glad you bring that up. I'm old school in that regard. I've learned a combination of, textbook knowledge, mentors, formal education, on-the-job training, tremendously important. Listening to people. You can learn from everyone and everybody, so take time to listen to them. But in terms of the research, the testing that happens, that takes place through various entities. The Battelle Memorial Institute is another one. EWI,
Yes.
MPC, incredible work. University of Tennessee in Oak Ridge, NACE, and others. I think it's important to understand where we've been and what the challenges were in the 50s and the 60s and the experiences we'd had with brittle failure, the Liberty ships, the welded construction that was being used to produce World War II vessels, the steel quality at the time, the temperatures of the vessels in the ocean, in the harbors, and how the failures were happening at stress raisers, at T-junctions, and how the testing revealed that steels that had impact testing values at operating exposure temperature of less than about 10 foot-pounds were the ones that were experiencing brittle fracture. And some people say that's where the first value of 15 foot-pounds Sharpie V-notch came from, because the testing revealed that brittle fractures were happening if the steel test temperatures, say 30, 45, were failing at, less than 10 foot-pounds. They didn't see if they had, so they added a safety factor of 50% and said, let's make the value required 15 foot-pounds. I maintain and still have textbooks from the 50s, 60s, some ASME handbooks on pressure vessels and materials engineering, old code books, old ASME Section 8, Section 2 code books. I think it is important to understand where the industry has been. And I'd say we're doing a good job of doing the fundamental testing and research and study. We did that with temper embrittlement. We've done that with stress corrosion cracking. We have done that and continue to do that with high temperature hydrogen attack. The learnings continue. We're getting more knowledgeable and learned in our ability to evaluate and predict. There's volumetric models now, crack growth, fissure joining, diffusion models. It's incredible what some very knowledgeable people have been able to educate us on through WRC bulletins. Is really is a nice place to start to introduce the industry and garner acceptance and understanding. And even now in NDE, what is the best NDT technique? Time of flight diffraction, phased array analysis, background scatter. We've learned a lot there and we've advanced, and those learnings are now have been incorporated. And the other one we continue to learn about is stress relaxation cracking. Right, the damage mechanism that affects austenitic stainless steels, nickel-based alloys, some iron nickel-based alloys, and the phenomena that happens really, 550C to 750C, and to control that and manage that. So it really is important. So I would encourage people, always learn, always continue to learn. The more knowledge and understanding you have, I think you can be more effective in expressing and identifying and preventing. And there's tremendous learning sources today. The internet is incredible. The amount of information you can accumulate and acquire. Inspectioneering Journal is on my top 5 list of places to go for information and knowledge because of the authors that you all have assembled and that the people that are willing to write, my hat's off to those people. The John Reynolds of the world, Heinz Block, who used to write tremendous articles for hydrocarbon processing reliability. John Reynolds, what he's done for the industry through API, through technical presentations, conferences. A book I kept with close to me and still have is 101 essential elements in a pressure equipment integrity management program. I mean, that book was dog-eared and feathered edged because I was into it so much. And that book and the information he conveyed just made such a huge impact on me, and ultimately was the source of probably a half dozen to a dozen special emphasis programs with the companies I've worked with, because they were areas we weren't performing very well. So I know I've been all over the place. The question was, the technical content, how important is it that we keep a record? We access those records. We try to understand. We reach out. It's essential to keep moving forward. One of the false impressions, I think, to broach another topic about our industry, and chemical plants are viewed as, oh yeah, they're old and nasty and they've been there for years, and there's probably not a lot of exciting things and technology going on, in those facilities. They're probably producing, and it couldn't be further from the truth. Not only in the processes and the process controls, the process monitoring, the use of AI to judge how the process is performing, where the process needs to go, data acquisition, deciphering the learnings from data, the knowledge we have about materials and corrosion and damage mechanisms, and tools to improve the situation, to gain a better understanding, to monitor, to assess. It's just been a phenomenal industry from my perspective, and how far it is advanced and how it relies on state-of-the-art knowledge and technology to continue to improve. So I would say to people, young people at some universities, there's some really good junior colleges. I think of San Jacinto College, I think Lee College. I think they're doing a great job in the area of process technology, non-destructive testing, fixed equipment testing. I think there's a lot of ways to acquire and obtain information. And for me, I've learned so much from books. I know I met John Reynolds once at the podium at a API equipment inspection conference. I don't expect him to even remember who I am. It doesn't matter, but I feel I've learned so much from him. Heinz Block, as I said, John Reynolds, and some of the authors today that are prolific writers. And I respect people that are good writers and write well. I don't count myself as one of those. And I'd say, again, if I have to ramble a little bit and pass on a piece of advice, become versed at verbal communications and presenting, right? PowerPoint presentations. Don't underestimate the value in being a good presenter, and take those opportunities. Don't always look to pass them to someone else to make a presentation. If they're going to give a presentation on what the fixed equipment inspection analyst has learned or believed, to ask the person who may be presenting that if you can do that section, and become positive and comfortable in that environment. It can only help you in your career and your profession if you're a good communicator. You write good emails. I would have benefited by AI today. I mean, you can get AI, some of the free ones, to help you draft and craft some language. Now, be clever enough to leave out the words that are above what you would normally use in your correspondence. But I mean, there's just a lot of good people that are willing to take the time to write articles, and they really serve the industry well, and I respect them, and my hat's off to those people.
So, Bill, you went over some soft skill stuff here that's really important. I know it's important. Like when you make a recommendation to do all your homework, to understand the dynamics behind the scenes as to
Yeah.
kind of what's going on. And I think communications are key. In fact, you may get a kick out of this. I've been doing RBI since the late mid 90s. And one of the people that I always want to make sure when I'm doing a validation, whether it's a DMR or mechanical information or whatever, but especially the process information, is make sure the chief panel operator is in there. That's the guy or girl that knows what's going on in the middle of the night when nobody's looking. They typically are more knowledgeable than the process engineer when it comes to day-to-day operations and what's happening. So can you speak to that a little bit about, because you did a little bit earlier about operators and how important it is to get good communications going with those guys?
Yeah, absolutely. Absolutely, Greg. That's an important point. And I applaud you for recognizing the importance of having a chief operator, the board, the lead operator of a process unit involved. It's essential. I would say it's essential. My 3.5 years in operations, where I was responsible and leaned heavily on operators and process chemists and technologists of those units. But what you learn about is how they manage and work the unit and juggle many things in the unit that aren't optimized at any particular time, right? So it isn't that you learn things devious or clandestine things that, they're
Right.
trying to put over.
Yeah.
It's just the real world of, the feedstock quality and where the treater bed, where the alumina bed is performing. It's the alumina fracture. It is the mole sieve been over temped and it is not removing the impurities, water, oxygen, CO2, chlorides, whatever the impurities are, and how they have to manage it and how they tell how the unit and the process is behaving, which valves may leak through, how the temperature comes up when they bring the unit online. If they have water boots, how rigorous are they about, tapping and draining off, liquids from a decanter or, a drum? Is it done manually? Are they rigorous about that? Or is an automatic, semi-automatic level control system that dumps, on level detection? It is important. If you're not communicating or seeking to learn from someone who has firsthand knowledge of operating, you're probably not doing any better than 65, 70 percentile in terms of the knowledge, the potential knowledge that you could have in the knowledge that you're leaving on the table. So if you're having difficulty in getting that information, then you need to collaborate and work the phones, work the email, pay a visit, buy some lunches, establish some trust and confidence. Here's a way to do that. It's simpler than you might think. You go to the control room as a fixed equipment inspection analyst, as an inspector, as a maintenance superintendent, or a corporate materials engineer, and you talk to the operators and you ask them what problems they're having and what problems. I have a list. I have some time. I may be able to help you guys or ladies solve some problems. And that's how you build rapport. And in my case, I gained a lot of trust and confidence with operators as an operating superintendent. It was about a walkway. They wanted a walkway, a platform and a walkway from one section of the plant over to the polymer pellet tanks. Because without a platform, because the original structure had a man lifter elevator up to the 5th, 6th level.
Wow.
Right. And so with a walkway, then they could get over to the top of the tanks and they'd have to bang on the tanks and do a physical verification of the level inside these solid handling tanks. Before we had a walkway over to the top of those tanks, they'd have to go down to the ground floor and literally walk up, old-fashioned staircases. And they were supposed to check the level 2 times a day. And so I took on that under the guise of a safety program, personnel safety, wear and tear on your joints. And I got the budget and got that implemented. Okay, so that's how you get a list
Nice.
of 10 things they want to see done. You be honest about we can't get all of these done, but whether you're in maintenance or engineering or inspection, ask what difficulties they're having operating, what valves, what's problematic, and try to influence an improvement for them in that area. And that's a great way to gain trust and earn friendship. I'd say the other way is, and this seems so obvious, but when you're pressed for time, you have to learn some things from the school of hard knocks. So this is again about trust and delivering on promises. One of the activities back in the early 90s that operators were responsible for was the fire extinguisher inspection checklist, right? You in a unit, you all know it, you have fire extinguishers positioned in the unit. And those need to be inspected monthly, as I recall. You had to look for corrosion. You had to look at the gauge, the pressure, the hose, evaluate it, assess it. And of course, we had a check sheet for that. And so every month they'd go out and do that and turn in the reports to the operations supervisor, who'd ultimately turn it in to the superintendent. And the superintendent at the time, it's not the case anymore that the superintendent is responsible, to get a replacement extinguisher or get service implemented. But it was at the time. And at first, when I first took over the job, I was drinking from a fire hose. I'm a mechanical materials person now in operations. So, that was out of my comfort zone. But I wasn't giving enough priority to resolving the fire extinguisher issues. So after probably 2 or 3 months of the operators seeing that they were reporting the same issues and they weren't getting done, guess what happened to the quality of the surveys of the fire extinguishers and the reliability? Probably said, look, if it's not important to that fellow to get it done, why should I take the time and give a good effort? So, I initially got frustrated and, probably was headed down to the control room on my bike to call someone out on that, but I had enough sense to realize that I was the problem. So everything matters, every word, every relationship, but there's ways to garner trust in those associations that will make a difference. And having a good relationship with operations and maintenance is important in a manufacturing facility in the petrochemical or refining industry.
Bill, I want to thank you so much for your time joining us today.
You're welcome.
This has been awesome. Thank you for listening to Upon Further Inspection, a Mechanical Integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wu. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcasts. Until then, stay safe and stay informed.